All right, everybody say hi, Erica and Bo.
Hi, Erica. Hi, Bo.
All right.
Colton.
And
Hi, Bo.
Colton's watching this right now, so he wouldn't be watching it. All right. So 6-2 notes is very similar to what we've done already. Normal distributions, again, this is the formula that you need to have memorized. Some of you probably do already. X minus mu divided by the standard deviation. Okay, that is how to find a z-score. Commit that to your memory, commit that to your brain. Okay, the way that these z-scores are set up, the P stands for the probability. Okay, and they kind of resemble probability to area underneath of the curve, okay? So if I'm looking for the probability of like this x right here, that would be from here on back. Okay, I know that probability is going to be fairly high, right? Because he's more than 50%. He's more than half of the curve. So kind of as you're doing these, especially you guys have the homework assignment in front of you, as you're looking at the shaded region, kind of check your answer over to make sure that that's what your area looks like. Does your area look like it's 75%? Does your area look like it's only 10% shaded? Whatever, okay? So look at those things. All right, let's go to example 1. We're going to just jump right in. The heights of men are normally distributed with a mean of 68.6. Standard deviation of 2.8. Write those things down, and then you don't have to reread. Okay, mu and sigma, standard deviation mean. They want to know, find the percentage of men who are taller. I'm going to write that down too. Taller than 72. Okay, my average here is 68.6. And I want to know taller than 72. 72 is going to be, I don't know, somewhere over here. Let's find our units here. What's 68.6 plus 2.2 or 2.8? 71.4. 71.4. So 72 is going to be a little bit more than 1, right? Okay, how do I figure out what 72 is exactly? The formula. Okay, so I'm going to do z equals x, which is 72, minus 68.6, and divide by 2.8. 1 point something. .21, always round to 2 decimal places because that's what the chart will go by. So this guy is a 1.21 z-score, okay? I want to know what percent are taller than 72, okay? So I want to know from here, this direction, okay? So what are we going to have to do? Look it up the chart left and then subtract from 100%. So I want 1.21. I'll write it down here again. 1.21 in the chart. Are we on the positive or negative? Positive side. Where's my chart? Oh, up here, right here. Positive chart, 1.21. 1.21 is the first column right here. We're doing this one and this one. 0.8869. Yeah? Okay? All right, so 0.8869 is this percentage from here on back, right? Now I have to subtract that from 100%, which is like 11.31. 11.31%. Okay? Does my shaded region look like it's 11.31%?
Yeah.
Probably, right? Okay? So 11.31% is how many people approximately are taller than 72 inches. Okay? Good? No. Oh, McLean?
Huh? Yeah.
All right. The U.S. Air Force requires that, so you would not fit in the shower head. Like, you would have to have it extended up.
Yeah.
That's what happened when we bought our house. Our house, like, the lady who lived in there was like 5 foot nothing. And so it fit me just perfect. Like, the shower head was down lower, and then my husband had to raise it. He had to go into the wall and do add some extra piping and stuff. Yep. All right, U.S. Air Force requires a pilot to have a height between 64 and 77 inches. That's not an average. Okay, those are my X's. I have 2 X's in this case. Okay, the mean is 63.7. Let's write that down. And the standard deviation is 2.9. Okay, so let's put that on our chart here. 63.7. If I add, somebody want to give me the add and subtract just for a couple of them? Actually, let's just do the add part. What's the add part?
666. Oh.
Woo! Okay.
69.5. Nice.
Okay.
72.4.
72.4.
Yep.
Holy crap. Okay. We are wanting to know what percent of people live in between a 64 and a 77. 64 is going to be about here. 77 is going to be like all the way over here, right? Okay? So, z-scores for 64. What's the z-score for 64 going to be approximately?
0 something.
0 something, right? It's in between 0 and 1, okay? So 64 minus 63.7 divided by 2.9. Somebody got it?
1, 0. Yeah, just 0.1.
0.1.
Yep.
Okay, 0.10. Is that what it rounds to?
Yeah.
Okay. All right. Always do 2 decimal places just so that you're, yeah. 77 minus 63.7 divided by 2.9. What? 4.59. Okay, 4.59. All right. So I want to know in between those two, this chunk here and
So
this
you just average
and this
them
chunk here.
Take the mean, right?
No,
No, you find the
No.
range, don't you?
we have to find that value. So I have a z-score. The z-score here is 0.10. The z-score here is 4.59. Okay? I want to look those up in the chart. They're both positive, and that's going to find me from here on back and from here on back. And I want to subtract those guys, right? Percentage from there on back. Okay, so this way we'll get to that. Find 0.10 on your chart.
It comes out to be 0.4602. When you subtract.
0.10 is this guy right here, 53.98.
Yeah, and subtract.
Okay, hold on, just wait a second. Just wait a second. We don't want to subtract that one
Why not?
because we want to
We were not
subtract them from each other.
Oh, goodness.
Oh, I see what you're doing. Okay, I wouldn't do it that way. 0.5397. You could do it that way, Cody. I see what you're saying. I see what you're doing, but I wouldn't do it that way
Okay.
because you're going to end up subtracting twice. I would just leave them the way that they are and subtract them from each other. Okay? All right, so 0.5397, that is what is less than a 1, or 0.1. Okay? Now, we're looking at 4.59, okay?
0.9999.
If you look on the positive chart, 3.5 and up is 99.99%, okay? Some of you guys have found it. So anything that's larger than 3.5 as a z-score is like way off the chart. There's 99.99% of people that are below 3.5, which should be right. Like 77 is like a huge number, right? So 99.99% is from here on back, okay? And I want to know what's in between those two. So then subtract those guys. So 0.9999 minus 0.5397, and you get something. 4602.
01.
Oh, it's supposed to be 5398. I wrote that down wrong. 4601. 4601. So 46.01% or 46% of people are between 64 and 77. So basically what this means is 46% of all people.
All women.
Oh, women? Are we talking about women? Heights of women. The U.S. Air Force requires that pilots have heights between those two. So only 46% of women approximately are accepted into the U.S. Air Force based on height. And then they probably go through another requirement that is like your physical fitness, like are you even a good pilot, that type of stuff, right? So starting baseline, only 46% of women even get in based on height, right? Okay? All right, example 3. When designing equipment, one common criterion is to use a design that accommodates 95% of the population. Okay, we're going to be working backwards this time. This one's going to be a little trickier. In example 2, we saw that only 46% of women satisfied the height requirement. That was what we got. Yay, we did that right. What would be the maximum acceptable height of women if the requirements were changed to allow the shortest 95% of women to be pilots? Okay? So, shortest 95% means we're separating basically the 95th percentile. So here's where 0 is. 95% is from here on back. 95%, and I want to know what this z-score is. We're looking at this backwards, right? What would the height have to be? That is, find the 95th percentile of heights for women. I'm going to write down the mean. Mu is 63.7. Standard deviation is 2.9 again, just to recopy that down. All right, what are we doing first?
Let's fine with that 95%.
Okay, so convert that 95% to 0.9500. We want to do 4 decimal places. And then we need to find the z. So we're looking this up backwards in the table. Are we on the positive or negative? Positive table. We want 0.9500. Amanda says that there's a star because it's exactly in between those two numbers. 0.9500 if you follow down. 1.645. Okay, that's another number that you probably should commit to memory because 95% shows up a lot. It's 1.645. So remember that. If it's 95%, 1.645. Okay, that's the number that you should use. All right, that number we actually do use a lot. So 1.645, but that does not tell me that. I want to know what is the height for 1.645 now. So you can do z equals x minus mu divided by standard deviation. Z is 1.645 equals x is what I'm solving for. 63.7 standard deviation is 2.9. Okay? Multiply by 2.9 to get him across. All right. X minus 63.7 equals that thing. Is that after you added it?
48.47.
What was it before?
It's 68.475.
No, before you add the 63.
Oh my god.
I write all my work down. Sorry. 4.77. Okay, now add the 63.7. Sorry, I'm writing all my work down. 68.47 equals x. So, if you are taller than 68.47, you are in the tallest 5%, right?
That's me.
95% of people are shorter than 68.47 inches. Let's see if we answered all the question. In addition to the maximum allowable height, should there be a minimum required height?
Yes.
Yeah. Why?
They might not reach the pedals.
They might not reach the pedals. That's the big one. Woo! So, maximum, they're probably going to have us do minimum here in just a minute. Oh, maybe they're not. Maybe they're not. Anyway, so maximum height requirement would be 68.47 because only 5% don't meet that, all right? Again, significant high, significant low. Anything that is less than 5% is considered to be significantly high, significantly low, whichever one they're looking for. It is significant if it happens less than 5% of the time. That's for both high and low. If it happens less than 5% of the time, it's significant, whether it's high or low, whatever you're talking about. Okay? So example 4, use the preceding criteria to identify pulse rates of women that are significantly low or significantly high. Assume that women have normally distributed pulse rates with a mean of 74 and a standard deviation of 12.5. All right, so here we go. Here's 0. I want the cutoff, or to find where the number is for the tallest, or excuse me, the highest 5%, the lowest 5%, because they're saying significantly high or significantly low. That means 5% here is the cutoff and 5% here is the cutoff. That's my significantly high, significantly low. Does that make sense?
Yep.
Okay. All right, so I need to find those z-scores. Z here and z here. Okay. I want to figure out what percentage this guy is, but it only measures from there back. What percentage is from here back? What percentage cuts off here and is from there back? 95%. 95%. Okay. What percentage is from here back? 5%. Okay. All right. So, what's the z-score for 95%?
1.64.
You should remember that. 1.645. We just looked that up in the table. What's the z-score for just 5%?
Oh, hard question.
No, but Tony, what are you doing?
Oh.
Negative 1.645. They're both the same spot, right? Okay. Start thinking smarter, and then you can cheat, right? You don't have to do as many steps. So I want to know where those cutoff marks are. So what do I have to find yet?
You got z-scores, so find your x's.
Find the x's. I need to find out exactly how many beats per minute that is. So 1.645 equals x minus the average, 74, over 12.5. That's, if you need to write the formula out again, here it is.
Multiply through.
Multiply by 12.5.
20. .56.
20.56 equals x
Plus-
minus 74.
Plus 74.
74.
94.56 equals x.
94.56.
Yep.
Okay, that's your
Then you
high.
gotta do the opposite.
Do the opposite. So, hold on. Just wait a second. Just wait a second. You don't have to redo it.
Oh,
No. No.
When you do the opposite, it's just going to change. It's got to be
Subtract 20.
negative.
Subtract 20.
It's 74 minus the 20.56, right?
Add 37. Bark, 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 bark.
What?
What?
No, that's not going to work.
74. What?
Wait, what?
I got 74.
No, you didn't. 74 and 20 minus 20.56?
53.44.
53.44.
Oh, that's right.
What?
That's right.
And you said subtract 37?
Yeah.
From where?
You don't understand.
From where?
Hmm?
From where? For what number? I don't know. You're wrong. All right. So what does this mean? What does this mean? We got
It means
94.56 and 53.44.
90% of the heart rates are between 53.44 and 94.56.
That's a good way to put it. 90%. Where did you get 90% from?
Because 95 minus 5 is 90.
90% is here, right? 90% of the heart rates are between these two. 90%. Okay, we could have said 5% of people have a heart rate that's higher than 94 and 5% have a heart rate lower than 53, right? Okay? There's lots of interpretations of what we just found. Good? That's it. That's all we have, right? Woo! Woo! Okay, so you guys have this sheet. Let's go through like number 1 real quick just to see what they're saying.
Let's do 1 through 10.
Just wait. Number 1. The mean is 100. Pull that out of the paragraph up here. The standard deviation is 15. Okay? You don't necessarily really have to do the formula. 100 is here in the middle. What's the z-score for 115?
1.
1, right? Because he's exactly 1 standard deviation ahead, right? If you need to do the formula, you sure can. Does that make sense to you, though?
Yeah.
If the standard deviation is 15, it's 1 higher, right? That's the z-score is 1. So, they are looking, if you're looking for this, where the shaded region is this guy, from there back. So, what percent is from 1 and back?
84.13%.
If you look it up, is it 84.13%?
Yep.
Okay. Looking up on the positive chart, 84.13%. Okay. Good. Do you guys see which region is shaded in number 2? Okay, this one. So you're going to have to subtract. All right. Are we good to go? Do you want to look at 3? Yes?
Sure, might
Okay,
as well.
sure, might as well. Average is, 100. Standard deviation is 15 again. All right, so 100 is right about there. So I'm going to have one of each table, right? 105 is on the positive, 75 is on the negative, all right? Let's figure out the z-scores for each of these guys. Z, that's what I need to find, okay? So I do 105 minus 100 divided by 15. And I do 75 minus 100 divided by 15. Okay? Anybody got them?
0.33.
0.33. Okay? And negative 1.67. Perfect. Okay? All right, so on the positive table, look up 0.33. What's from there back? And look up 6293. Okay? And negative 1.67. 0.0475. Okay? All right, how do I find the area between them? Subtract. 0.6293 minus 0.0475. What? 0.5818. So 58.18% of people are between 75 and 105 for whatever we're talking about. What are we even talking about?
No idea.
IQ scores. 58% of people have an IQ between 75 and 105, according to this. Right. Okay, good. Some of these regions are a little bit lighter shaded. Number 5, they give you have to look at backwards, right? They give you 0.9, which is 0.9000 if you look it up as 4 decimal places. Okay? So that one's backwards in the table, like what we were doing on the notes, all right? I will give you the rest of the time to work. Okay? Good? All right, everybody say bye.
Blah, blah, blah.